it, and how do you use your newfound Tableau skills to, find connections across the world, share your work, and, continue to build your visual analytics skills. So if that all makes sense, we can go ahead and get started with the science of visual analysis. Great. All right, so the science of visual analysis. What is analytics? Does anyone want to, give a definition of what they think analytics is? Anyone have any ideas? You can write in the chat or you can unmute yourself.
Hello.
We can hear you.
Okay, I think analytics is working out big data and getting insights from data, basically.
Absolutely. Yep. Yeah, that's almost exactly the definition I have here. So what is analytics? Analytics is defined as the scientific process of transforming data into insight for making better decisions. So great work with that. So what we're going to talk about with the science of visual analytics is what we can do to make the analytical process the best for our users as builders in Tableau. So analytics, it's not just the description of information, but it goes beyond that. So we can examine and explain the information that we're seeing. So we're going to start with a little exercise here around visual analytics. I'm going to show a grid here of all numbers, and what we're looking for here is specific points of data that we're going to pull out of here. So this is an example of data. This could be anything. This could be numbers like we see on the screen. This could be retail data if we're working in the retail space. This could be how many grants our nonprofit has given out that year. Data can really be anything. So what is visual analytics then? And how do we tie visual analytics with data? Visual analytics is the representation and presentation of our data that uses our visual perception and our human nature in order to help us and amplify cognition, in order for us to be able to draw out the patterns. So basically, what we're going to see here, again, are numbers. So this is the little exercise we're going to do. We see this whole pane of numbers, and what we're going to look for is the number 9. So if everyone can go and look at this screen and count every single number 9, and you can write in the chat or unmute yourself when you have the answer.
Sorry, did you say we should locate all number 9s?
Right, count the 9s that you see, and then let me know when you've counted them.
Wow.
All right, looks like we have some answers in the chat. Okay, great. So let's try that exercise one more time. And I'm going to show a new slide. Okay, now count the 9s. Awesome.
10.
Yep, exactly. So the point of this exercise is when I showed the first slide there and the 9s were not highlighted in red, it took 15 to 20 seconds for anyone to even get the answer there. As opposed to when I highlight the 9s in red, it takes between 4 and 5 seconds for you to get the answer. So this is an example of visual analytics. In this example, we're using color to highlight the information that's important for the user so that they can gain their insight quickly and easily. So this is just one of the design concepts that we're going to talk about today with Tableau, how we can use the concepts of visual analytics to allow our users to get to their answers and their insight quickly and easily. Awesome. So let's now look at some data. Here's another example of data here. We have 4 sets of data here, each with 11 sets of XY coordinates. So we have 1, 2, 3, 4 up top. Each of them have X and Y coordinates. So for the purpose of this exercise, let's assume that the X data represents in millions the net sales of a retail store over the course of a month. And then let's say that Y represents the total profit in millions from that store. So we're looking at here at a set of points that represent profit and sales, where each point is a single store. So the 4 data sets represent regions. So 1, 2, 3, and 4 could be Western region, Central region, Southern region, and Eastern region. And then the X and Y coordinates represent sales and profit for each individual store in one of those 4 regions. Okay, so we have a little bit of more information here down below. Typically, we'd have some more information when we're making a decision here. So let's look at some information about these data sets. So obviously, looking at the first data set, we can, as humans, try and read and understand and try and look for patterns there, but we don't have, a lot of information here helping us out in terms of visual analytics. So there's some statistics now in the bottom that can help us a little bit. We can look at means, variances when we're crunching numbers. We can look at correlation or do a linear regression. So it turns out that all these 4 data sets each have the same means, the same variances, the same XY correlations, and even have an identical linear regression. However, when we look at this visually, we're going to see a different picture. Okay, so here's the same 4 data sets, but plotted visually and with trend lines. So now that we can see, even though the statistics for each of those 4 data sets are exactly the same, when plotted visually, we can see that each of those data points look completely different when we plot them out like this. So if these were all, regions for stores, for example, when we were looking at this, maybe you'd want to, talk to the manager of the outlier in set 3 and see what they're doing right. Or maybe you'd want to look at the stores in set 4 and see why their profits are underperforming compared to stores with similar sales. So when you look at this data visually, even though all the statistics lined up exactly the same, you can see things that you weren't able to see before just looking at, an Excel, for example, of data, just, the numbers themselves. So when we plot things visually, we're able to see patterns that aren't immediately apparent when we're just looking at the set data itself. Awesome. So a little bit of an introduction to visual analytics and why it's important here. All right, so now we're going to talk about human perception and cognition, like what we saw in the 9s example, why we can pick out red, for example, instead of just looking at the straight data itself, why we can pick out visual patterns easier than just looking at the data. Then we're going to talk about the visual analysis cycle and some visualization best practices, specifically using Tableau. Cool. So we're good at some mental math as humans. We have an area of our brain where we store quick responses to certain stimuli. So we know, for example, that 3 times 7 is 21 because we've learned that in school, and these facts can occupy part of our brain that has a quick response. However, humans are not so good at other mental math. So we're not designed to manipulate complex numbers in our heads. Another area of our brain is used for more complex processing. So if I gave you a pencil and paper to solve that problem, all of a sudden this becomes a lot easier to solve. But how much easier is that when you have pencil and paper? It's about 5 times easier. So it takes educated people an average of 50 seconds to solve this problem in their head. But when you give people the right tools, suddenly it's solved in just under 10 seconds. So the analogy here between the pencil and paper and Tableau is the tools that we're giving people to answer these problems. We're faster when we can see data. So looking straight at this crosstab right here, what product subcategory is the most unprofitable? if everyone's looking here, of the subcategories. If someone wants to call it out or type it in the chat. Which subcategory is the most unprofitable? Great, looks like I see some answers in the chat here. Okay, great. So the point here again is it takes some time for us as humans to read through this data and understand what we're looking for and then be able to call it out. So to answer this, you either scan the table from top to bottom and column by column, or from left to right and row to row. So evaluating each of these 60 data elements is pretty taxing to the brain. However, now that we've added the element of color onto this visualization, we can now call out the subcategories with negative profit much easier. Just like with the nines example, when we add just a single visual element like color, the processing time gets cut significantly. So we've gone down from scanning all 60 items here to just 16, which are showing negative profit here. So we're narrowing down the data with this visual cue and allowing the processing to happen much faster. But what if we made it even better? So now it's pretty apparent which product subcategories are the most unprofitable. Now that we've added color and size, as well as orientation to the visualization, we're able to see much easier our unprofitable product subcategories. So comparing from just the straight cross-tab of data, for example, something that we'd find in Excel, to this visual representation of the data, we cut that analysis time significantly, allowing our users to quickly draw out the insights that they want to see. For example, right here. Awesome. So why is this the case? So this has to do with pre-attentive processing. This is, part of human nature. Many thousands of years ago, we had to respond quickly to color, size, location, and movement. And those with quicker pre-attentive processing survived, perceived threats. For example, we can see the lion here in the grass. Pre-attentive attributes are information that we can process visually almost immediately before sending the info to the attention processing part of our brain. So this is information we understand almost unconsciously. These are generally the best ways that we want to present data when we're doing visual analytics because we can see patterns without thinking too hard. So these attributes evolved in response for us as humans to quickly assess the situation, find a pattern, and then choose whether to react. So here's a couple of examples of pre-attentive visual attributes on this slide. We have length, width, orientation, size, color, like we saw before, positioning, enclosure, etc. And we'll be utilizing all of these concepts when we're working with Tableau Desktop to help our users draw insight. Again, we have a couple of other attributes here that help users understand data when placed in a visual analytics manner. So this is an example of a Sumerian tablet from around 2000 BC, and it's one of the first examples of writing. So writing was originally developed by the need to count items, gold, salt, number of fields, and the need to record who has what amount of items. So the key thing to consider is that we've been using pre-attentive attributes to make decisions for about 200,000 years, whereas we've had numbers for only about 4,000 years. So at most, we've used numbers for only 2% of our evolutionary existence. Right, so attributes are universal, whereas numbers are not. For example, we have right here, numbers written in a different language. And so what we want to utilize when we're doing visual analytics is those pre-attentive attributes. Okay, so the cycle of visual analysis. Visual analysis isn't just looking at a chart or using colors. It's a life cycle that includes identifying, getting your data, establishing the structure of that data, choosing the best way to visualize it, drawing conclusions and insights, getting buy-ins on those conclusions from your collaborative team, and then maybe supporting the whole cycle over again. So visual analysis is definitely not a linear process. It's very cyclical in nature. So supporting the cycle. So part of this is how Tableau works. These are supporting the cycle of visual analysis. So Tableau is incremental. It allows people to easily and incrementally change the data, how they're looking at it. Tableau is expressive. There's no single view for all tasks and all data. Tableau is unified. It leverages changes in database technology that ease the cycle of analysis. And it's also direct. So one of the greatest parts of Tableau is that when you're using Tableau Desktop, the tool itself really disappears and you're directly interacting with the data. So Tableau, the way it's built, it's designed to not take you out of the flow of analysis. It's designed to have you be able to ask and answer your questions quickly and easily and not interrupt those conclusions that you're drawing. Okay, so before we get into getting hands-on with Tableau, let's talk a little bit about some visualization best practices in Tableau. So like we saw before, we always want to represent data for humans. We want to use color. Maps are great when we're doing geospatial-based data. And then we're going to talk a little bit about creating dashboards. Types of data. Okay, so we have three major types of data here: qualitative or nominal, qualitative or ordinal, and then quantitative. So we've got in Tableau, we tend to look at these things in two different ways. We look at our quantitative data as measures, which I'll explain a little bit more later. And we look at our qualitative data as dimensions. However, within the category of dimensions, we have nominal data, like, for example, names of states, names of people, or names of products. And then we have ordinal qualitative data, which are kind of degrees, for example, excellent, good, or poor, love it, like it, hate it. So it's more of a range or a spectrum there. So how do humans like their data? Again, thinking back to those pre-attentive attributes, these are the things that we want to think about when we're arranging our data in Tableau. So position, length, size, color intensity, different shapes, different colors. And so we have those three types of data that we just discussed split up here. And these are different suggestions on how to visualize those types of data when we interact with them. When it comes to these different pre-attentive attributes, there's a couple more that jump out right away, whereas some that take a little bit longer to process. So position would be more important here, followed by color, size, and shape. So here's an example of a dashboard. So this is showing a couple of visual best practices here. We have time down in the bottom on an x-axis. We have location shown on a map here. We're also comparing values in the bottom right on a bar chart. So we can see that we're using visual best practices in terms of color and the way that the data is arranged in terms of what visualization type has been selected here. So this is an example of a dashboard created in Tableau using some visual best practices.